Hello students, welcome to another lecture of random process and information theory. Since we are dealing with the unit 4 of random processes and information theory, today we will discuss about cross correlation function. Uh, we have already discussed regarding autocorrelation function and its properties. I have also shown proof for the autocorrelation properties. Now we will show what do you mean by cross correlation function and what's its significance. So cross correlation function, as I have written here, is of a two continuous time jointly wide sense stationary random process x of t and y of t is defined as r x y of tau is equal to expectation of the product of x of t. It's one random process, and this is y t of tau is another random process. That means cross correlation function is just the product expectation of the product of two random processes, and these two random processes should be different. If by chance these two random processes happens to be the same, that means they are x of t and x of t plus tau, then that is nothing but your autocorrelation function. Then this will be written as rx x of tau. Done. So this is for the continuous time random process. Now similarly for the cross correlation function of the two discrete time jointly wide sense stationary random process x of n and y of n is defined of r of x y k is equal to expectation of the product of x of n and y of n plus k. So you have defined I have defined this cross correlation function for continuous time joint wide sense stationary random process x of y, x of t and y of t. Similarly, I have shown for two different random process x of n and y of n, and these two are discrete time jointly wide sense stationary random processes. I have already defined in my previous lectures what do you mean by wide sense stationary. That means the random process is said to be wide sense stationary if its mean as well as variance is constant, and its autocorrelation function should be dependent on the difference of the time. That's it. Now I will this is called quantitative method of defining the cross correlation function. Qualitatively cross correlation function, that means what is its significance? Cross correlation function is defined as the similarity in shapes of two different random processes, obviously stationary random processes, two different random processes x of t in case of continuous and y of t, and one of the two should be delayed function or advanced function. So what you can say from here, that you just try to draw the shape of x of t and y of t plus some value, that means tau. Try to draw its shape, draw its graph, then compare. How similar are these two? Comparison should be drawn. Compare these two graphs. Then you will try to see the similarity between these two graphs, and that's your cross correlation function. So if someone will tell you what's the difference between cross correlation function and autocorrelation function, you will simply say that in cross correlation function, you're just trying to see the similarity between two different random processes, obviously they should be stationary. That's one of the main point here. And similarly, autocorrelation function will be the similarity in the shapes of the same random processes drawn at x of t and xt plus tau or xt minus tau on the same thing, because autocorrelation function is an even function. Done. In the next video lecture, I will write down the properties of cross correlation function and then try to derive its proof. Thank you.